Hello everyone. In this tutorial, we are going to discuss the implicit function. So this will be a little bit different from our previous functions that we have discussed in the calculus series, in the sense that you discover that most of the functions that we have been discussing in the previous series deals with, let's say, y is equal to x raised to power 2, y is equal to x raised power n. Let me write another one. Y equals x raised power n. Let's say y is equal to 2x raised to power 1 over 2, and so on. Now, when you have functions like this, the functions we have been doing previously are called explicit functions, which means that x and y are not combined together to form an equation. That is, they are kind of, shall I say, differently, or they are expressed explicitly. So, but for an implicit function, what happens is that when you have your x and you have your y being combined in an equation, it gives you an implicit function. So it can be combined together, it can be separate, like x plus y. You can have x plus another xy equating to 0 or equating to any other constant. So, for example, let's take a very basic example. If we are to differentiate, if we are to differentiate x squared plus y squared to give us 4. Now, this is a typical example of an implicit function. So what it means is that we are going to differentiate each term separately with respect to the letter in which we are using to differentiate. So if we're starting with x raised to power of 2, if we differentiate x raised to power 2, you get 2x. So with respect to x, this will be dx plus, since it's a plus that we have here, if we differentiate y raised to power 2, you get 2y. With respect to y, this will be the y. Is equivalent to, if we differentiate 4 is a constant, so you get 0. So we'll divide through by dx because we want to make the y dx the separate formula. So if I divide this by dx over dx over dx, then it means that we'll be left with 2x plus 2y the y over dx to give us 0. So if we take this 2x to the other side, we're left with 2y the y over dx to give us minus 2x. So dividing both sides by the coefficient of the y dx, which is 2y, we'll have the y dx to give us minus 2x divided by 2y. So it means that the y dx is equivalent to minus x over y. So the gradient, which is a derivative at this of this implicit function, that is x squared plus y squared is equal to 4, will be equivalent to minus x over y. So let's assume that this question cell should differentiate x squared plus y squared is equal to 4. That is, find the y dx at the point 1, comma 2, which gives you the gradient at that particular instant. From here, our x is going to be equal to 1, our y is going to be equal to 2. So the gradient at that point, which we have defined as minus x over y, our m will then give us minus 1. Anyway, cx substitute 1 over 2. Anyway, so y will substitute 2. So that's a very first basic example that we are taking under implicit function. So let's take another example so that you get the concept very much clear. Another example, if we are to differentiate x raised to power of 2 plus 2xy plus y square is equal to 63. So find the y dx. So this is another implicit function. So we use the same approach for x squared. If we differentiate x squared, you're going to get 2x. With respect to x, this will be dx. Now 2xy, 2xy. We have two functions here. We have x and y. So this constant, you can group it with one of the function. You can group it with x or you can group it with y. The reason why you can do that is because multiplication is commutative. 2x times y is the same thing as x times 2y. So if I'm grouping it with x, this function becomes 2x multiplied by y. So when we are finding derivative of the product of two functions, don't forget we use product rule. So when our y is equal to uv, our dy dx gives us u dv dx plus our v du dx. So which means first times derivative of second plus second times derivative of first. So here we can take our first to be u and we'll take our second to be v. So our u will be 2x. Our v will be our v is going to be y. So if our u is 2x, of course you know your du dx will give you 2. If our v is y, that's differentiating that with respect to y. Okay, so now let's apply product rule here. So to differentiate 2xy, our first is 2x, our second is y. So first, this will give us plus times derivative of second. If you differentiate y, you get 1. With respect to y, this will give you the y plus second y times derivative of first. If you differentiate 2x, you get 2. With respect to x, this will be the x. So plus, so it means the derivative of 2xy is the whole of this. If you differentiate y square, you get 2y with respect to y dy. If you differentiate 63, you get 0. So if we divide through by dx, 2x plus 2x the y over dx plus 2y plus 2y the y over dx is going to give us 0. So let's collect like terms. 2x the y over dx plus 2y dy over dx will give us minus 2x minus 2y. So if I take this 2x to the other side and this 2y to the other side, it becomes negative. So let's factorize the y dx out of the left hand side. Our dy dx will give us 2x plus 2y is equal to minus 2x minus 2y. So what it means here is that the y over dx will give us minus 2x minus 2y divided by 2x plus 2y. So we can still solve this further because there's a correlation. If we factorize minus at the numerator, that's minus 1, we'll be left with 2x plus 2y, which will be the same thing as what we have at the denominator. So this will be able to cancel each other. The y dx will eventually give us minus 1. So that's the answer to that question. And basically, this is how you solve implicit functions. It's very simple and basic. See you in the next tutorial.